Good morning, everyone. Whoa, it's bright. Thank you for coming here bright and early on a Wednesday morning at reInvent. Based on past experiences, everybody spends Tuesday night working hard on technical content, and it's difficult to get up early. Just kidding. So my name is Deepak. I have been at AWS for over 11 years. I was here last year in the same theater, which is, by the way, gorgeous. Among other things, I am responsible for the containers and Linux organizations at AWS, as well as the open source program office. And having been part of EC2 for over a decade, it's been great to see and have a sort of bird's eye view of how customers started building applications on the cloud. They started off with simple stuff a long time ago. Those applications have gotten more and more interesting and more taking advantage of the core capabilities that AWS gives you and helping us build newer and newer technologies to help meet their needs. My colleague David Richardson is going to come in about halfway through. He's been at AWS even longer than I have. In his 13 years at Amazon, he's built some of the largest distributed systems in the planet, things like CloudFront, Route 53, EBS, and currently leads our serverless portfolio, which includes things like Lambda, API Gateway, and EventBridge. So last year, we were here, and David spent some time talking to you about how Amazon made a journey from having this monolithic code base to microservices, as they call it these days. We just call them services architecture. But it wasn't just about decoupling a monolithic application into smaller components, but also how we organized as a company to make it happen. And in fact, I think as we have conversations with customers as well, it's pretty clear that it's not one or the other. They both have to go together. This idea of two pizza teams and distributed applications and team autonomy is something that is built into our culture. It drives a lot of how we think about building services, how we operate, and you'll hear me come back to that concept often today. And the reason you do it is you want to give teams more autonomy, the ability to move quickly, more ownership, but there's trade-offs that come with it. One thing we realize as we have many, many teams running really, really quickly to build services that all of you use these days is sometimes you end up reinventing a lot of wheels. So it became very obvious to us that we needed to start building, quote unquote, building blocks to help these teams be more effective and not have every team reinvent the same wheel again and again. These building blocks essentially end up in two categories. The reason you do it is you want to reduce work to solve common problems. A great example of that is Amazon S3. Most teams, almost everyone, requires an object store somewhere where they can throw data up. They know it's going to be reliable. They know it's going to be there. They know it's going to be durable. Message queues are a similar concept, and you start building blocks like S3 and SQS to solve those problems, and any team can essentially pick those up and go off and is off to the races. Sometimes you have really, really hard problems, and you need a team that's dedicated to solving those problems that can then the rest of the organization can leverage. Networking is one of them. How many people here love building networks? Maybe a couple. I can't see anybody, so it doesn't matter. All I can see is these bright lights. So networking is one area. DynamoDB, building large-scale distributed key value stores, is again a hard problem. Operating them, perhaps an even harder problem. So you want teams that are dedicated to doing that, and then the rest of us as service teams inside AWS benefit from them. The good news these days is in many cases, many folks in this audience do so as well. So whether you're trying to address common problems like storage, networking, hard problems like distributed key value stores, finding the right building blocks is critical. But there's another part that's also critical is how do you expose those building blocks to people? Because if you just, and I think many of you know that, as you have more and more and more building blocks, what are the right abstractions that teams can benefit from? Otherwise, yes, they can get to choose from a menu of building blocks, but things get harder and harder in how you do it. That's become an increasing part of our thinking. What's the right level of abstraction? How do we expose these to people? How do our customers and us internally use them? So this mission has become very, very important to us. So David, myself, many of our colleagues, our product teams, talk to hundreds, thousands of customers every year. And what that's really helped us with is thinking through, okay, we've been really good at building building blocks. We've been shipping them for years. There was a bunch released yesterday on stage. But what are the right level of abstractions that we can expose? and how can we bring our best practices to our customers in ways that doesn't require them to think so much. And we'll talk about that a little bit today. So in general, today's talk is divided into 3 categories. I'll start off by talking about software delivery. How can teams deliver software more quickly, more safely? What are some of the best practices and patterns that we have seen both inside Amazon as well as with our customers? I'll talk a little bit about operational models and what those mean, especially in a serverless world. And then David is going to come out and talk about architectures and especially around event-driven architectures in particular. So hopefully this is somewhat similar to last year, but covers new ground. So let's talk about software delivery. So last year, Ken Exner, who runs our code teams, was up here talking about some of the core principles of software delivery at Amazon. One of the things that we learned a long time ago was that having a single deployment pipeline in a company doesn't make sense. It makes sense if you have one application and you're deploying them, but you have many, many autonomous two-pizza teams. How do you allow each team to move independently, to work independently, and deploy quickly? And a very simple solution to that, and it works reasonably well, is having a deployment pipeline per service. So let's say I have a team. They may have 3 services that they're operating. Every service gets its own deployment train. You have best practices that you can apply across all of them, whether you're doing config, whether you're doing patches, whether you're deploying software, whether you're updating infrastructure. Because everything is code, and hopefully you're putting it in a repo somewhere, you have the right checks and balances, you can now apply the same logical and good best practices across the board. Code reviews, unit tests, so on and so forth. But the key is allowing each service to have its own pipeline so that they can deploy independently and quickly. And that's worked really well. There are many ways to do this. Your classic way is, I have a new software system, I deploy the whole new software system, and there's a big restart, and you just switch over to that. As far as I can tell, not too many people do that anymore. The one that's most popular is what people call blue-green deployments. Netflix calls it red-black deployments, where you spin up a new version of the application, and then you switch a load balancer over to start serving traffic to that one. What we have realized over time, as applications get more and more complicated as they're built from many services, is that you need to think a little bit differently about what safe large-scale deployments mean. We call that fractional delivery, and it's become a big part of how we deploy software at AWS. And I think the community calls it progressive delivery. Both work really well. But the idea is that you start deploying, and actually I think it's best shown by this diagram, is you build your application, you have a bunch of tests, you start deploying in your pipeline, but you have a system that's constantly evaluating how that is doing. That could be a combination of a controller that's looking at drift from what you expect. It could be a set of what we call canaries, which are essentially a set of services, set of repeatable tasks that we think mimic customer behavior, traffic patterns, etc. What we do is we deploy it to a small number of hosts in one availability zone in one region. That's the starting point. You let it bake for a while, you look at the canaries, you look at traffic. This is in production. You slowly move that to once that passes, you move it to the next step. As you're building up traffic to this new application, you're slowly fractionally taking traffic away from the old application. Slowly, as all your tests pass, you'll end up deploying globally. Different regions have different traffic patterns, so you want to go zone by zone, region by region, have maybe different set of tests sometimes. But the idea is that anytime something fails, you just roll back, and you can bring traffic back to the original state as well. This has worked really well for us. It's a big part of how we're starting to think about our own software delivery pipelines that our customers use. But it's not just us who've discovered that. A great example of a company that is taking advantage of these is iRobot. But before I talk about how iRobot does it, they take advantage of one of the fundamental, they use Lambda a lot. And one of the things that Lambda has allowed customers to do is take your infrastructure and your application and mush them into one thing. So historically, for example, you had a team that would be patching your servers for you, that would make sure that your environment was ready to accept new software. Then you deployed new software. But what happens if you roll back? If you've patched all your servers, you put new libraries on them, and you roll back to a previous version, you almost have no guarantees that the new libraries will work with the old version of your application because it might have had different dependencies. It's actually one reason containers got really popular. But with Lambda, you can take it one step further because you can your application is your infrastructure and allows you to move very nicely forward. To look at how iRobot does it, I'll try and squint. How many people here have heard of iRobot and Roombas? Everybody, or most people. So for the two people who didn't raise their hands, iRobot is to robotic vacuum cleaners what Xerox was to photocopying, for those who remember what photocopying is. There are millions of robots all over the world, and a bad software deployment where you just roll off a deployment to the whole world at the same time, and everyone's robots stop working, somebody will think that the alien invasion has happened. They don't want to do that. They want to be very careful and very safe about how they deploy software. And they take advantage of fractional delivery to do that. So at iRobot, everything is configured in code. They deploy code, they have a set of unit tests, which they have written as Lambda functions. They have the step functions-based system that they use to scale it out. They're deployed using a Jenkins-based deployment system. They make sure that it's as slowly as they roll out. They continuously check both on the cloud side and on the edge if things are reconciling, if all the tests are passing. And over time, as they get more confident, then they roll it out to the whole world, and the robot uprising doesn't happen. This system of fractional delivery is one that may seem like it's more work, but actually it can work really quickly because everything is automated. Your machines are making the decisions. You are setting the criteria for what's important. And actually, in the end, it's much safer because your rollbacks are happening automatically. You're less likely to have outages. And this is a great example. And if Ben Kehoe is anywhere in this audience, you can always grab time with him to understand how this works. So we call this application first deployment. The key is you are focusing on what the needs of your application are. If you have infrastructure that your application depends on, you're either mushing it with your application, where it's just the same thing, like a Lambda does, or you're taking advantage of containers where you're sort of abstracting away the low-level hardware and focusing on the application needs and its dependencies in a containerized package. That works really well. But people want to make this a lot easier. They keep coming to us and said, great, you're giving us all these patterns. How about giving us tooling that makes these patterns more natural? We don't have to teach every engineer in our company what it means to deploy a service, what it means to deploy it safely, what are the right methods to build, what are the right scaffolding to build. iRobot is good at this. They built all the scaffolding. Other people come to us and say, please help us do it yourself. So one area we've invested a lot is CLIs and using command line interfaces as a way to help developers get there. But the CLI is almost the end state. A good starting point, and one thing we discovered was patterns and ways to take patterns and represent them in code. So a great example of that is the Cloud Development Kit, or CDK. I think when GA earlier this year, in CDK, you can take patterns or best practices and actually put them as CDK features or functions. And what then you can do is you can vend these to the rest of your company and say, hey, if you do it this way, it meets our best practices. So for example, if you want to run a load balance service with ECS, it's a few lines of code in CDK, and things will just work really well. But that's imperative code. It's not for everybody. If you're an operator, you might like CLIs, you might like Bash. What about them? So what we ended up doing was building a new generation of the ECS CLI. For those who have used Gen 1, it's essentially a mimic of the ECS API. Every command is like the ECS API command. It's just a command line way of calling the API. ECS CLI 2.0 takes these CDK patterns, essentially, and builds a domain-specific language on top of them. So with a simple command line call, you can run a load balance service, which will spin up services into availability zones. It'll put a load balancer on top of that, create the subnets, all of that for you, and it'll actually build the deployment pipeline as well to deliver that software. So we are automatically building software delivery, application-first thinking into the CLI. The idea is that things aren't static. You aren't describing all your infrastructure up front in a static file. You have something that's constantly looking at what your pipeline is, what kind of application you want to deliver, what kind of behavior it should have. Some people call this GitOps, which is a term that's become popular in the last few years. It's something that we think is great. These kinds of practices, I think, as more and more people adopt Lambda containers, I think it'll just start getting more and more common because they're just a little bit easier. And we have done something similar with Lambda. This is an example of the kind of calls you have with the CLI 2.0. You can initiate it, you can create projects, you can build an application, you can have commands at the level of an application, but you also have a whole software release process built into that CLI. And I think that's the part that we just didn't have in the past. But we want to make it a lot easier for people to build and deploy applications the way we think are safe and good hygiene. Lambda has something called start-write templates that are part of the serverless application manager. SAM is very analogous to CDK. You can have these patterns that combine things like package functions, APIs, databases, event sources into one template. You can have best practices described in those templates, and then you can use the SAM CLI, the command line interface, to do local testing, simulate these templates, build a deployment pipe train, and then go deploy these patterns. And I think you'll see us do a lot more of this, both on the Lambda side and the ECS side as well. And in the EKS side, we do the EKS CTL. The key is all of these projects are open source, so it's not just us building these patterns and deploying them. If there's things that you like to do, things that you think are more generally usable, not just within your company, submit a pull request, submit an issue. We're more than happy to work with you and try and get that done. So we've talked about software delivery. Software delivery is what allows teams to move quickly, to deploy safely, and as developers, as more and more developers are thinking about the end-to-end aspect of what it means to build and run software, the second part of it is how do you operate it? And how do people have the right tools in their hands to operate safely? Not just your ops teams, but also your DevOps teams and your developers. I mentioned earlier, one of the challenges with building blocks is you have a lot more pieces that you need to operate. AWS now has, 175 services. I might be completely out of date by now. And trying to figure out how to corral all of this together is a bit of a challenge. And we've started thinking increasingly about how we can help remove this complexity. So the question we ask ourselves is, what do developers need to build and run their application? That's the question we're asking ourselves all the time. And things that have come up again and again as we talk to them is people want to run applications. They don't want to it's true today, there are entire customers who have entire teams whose job is corralling their infrastructure on which their applications run. Whether they're building Terraform modules, whether they're building CloudFormation templates, whether they're trying to build a whole platform that they then rent to their application teams. That's a lot of work for a lot of customers that they would rather spend building things that have business value. It's a challenge. They want scaling to be quick and seamless. They don't want to think about it too much. And the last thing that's become increasingly important, especially as customers in more security conscious or regulated industries start picking up these modern practices, is how do we build security and isolation into the designs rather than something you have to work with a separate security team to work on. Because you can't move quickly if you always have to engage a team outside your org to figure out, hey, am I secure or not? And so these are some of the core concepts and centralized themes that keep coming up. So what do we do about it? Well, the first thing to remember and start off is the AWS responsibility model. You've probably heard us talk about it ad nauseum over the last decade, is AWS has a shared responsibility model. I like thinking about it in terms of EC2. If you have a box and there's a line in the middle of the box, anything below that line is AWS's responsibility, VM down. Anything VM up is the customer's responsibility, it's yours. What our customers want to do is want AWS to move that line further up. But they don't want us to move it to a point where things become a toy or your flexibility goes away so much that it's not that useful. So finding the right balance is hard. At AWS, the way we do it is we do it in 5 different ways so that there's 5 lines and you can figure out which one you want. That's been our approach so far, and it's probably not going to change. And over time, you might figure out once and for all that this is the right line and we'll just focus on that one. So you're making trade-offs between knobs, and there's customers who just want every single knob in the world, and there's others who are like, I don't want to look at a knob, all I want to do is run my software. I had this slide up last year. I don't know if it was this pretty, but I had it up, which is, I said cluster huggers are the new server huggers. And if anything, the last year has made that conviction even stronger. And here's what I mean by it. So this is a particular issue with container orchestration in general. A few weeks ago, I'd gone to New York, met a lot of banks, and inevitably, every discussion was about, should we run one cluster with a lot of applications? Should we run many clusters, each with its own application? Which instances should we use? How do we use namespaces? Just all this muck about cluster operations, which if you think about what EC2 did, nobody was thinking about which racks you were deploying to, which particular rack on which server my server VM was running on. we sort of brought it all back and actually added more complexity because you have to think about 15 other things. And so the cluster management that many people love, myself included, we've been running clusters for years and years and years, but then artifact of how things ran in a physical world. And I think a lot of what we've done in cluster container orchestration in the last, I would say, 5, 6 years is almost a regression from what we had done in the cloud before that. We made customers start thinking about capacity. And that seems to be a problem. So we've added what we call significant amounts of accidental complexity. What is accidental complexity? It was actually a term I'd never heard of till about 2 weeks ago, or 3 weeks ago. One of the senior engineers in my org, Jacob Gabrielson, we were writing a doc on simplifying the customer experience, and he used these two terms, essential complexity and accidental complexity. Essential complexity is something you cannot avoid. It is inherent to the problem you're trying to solve. Accidental complexity is the stuff that you don't care about, but it's there because somebody's made it your problem. A lot of what we are focused on, and we should be focused on going forward, is you have to focus on the essential complexity. That's what you should spend all your time on. How can we make that accidental complexity go as far down to zero as possible? So the area that I'm going to talk about is compute capacity, and surprise, surprise, for us that means serverless. So if clusters have brought back a lot of the infrastructure challenges that we thought things like EC2 had taken away from people, we believe serverless brings it back and makes customers think less about it. So with Fargate and Lambda, for example, there are no pets. There's no machine that you have to go babysit and figure out if it's running. How do you bin pack on a machine? Which application should run together? Those are things you don't have to think about. You're deploying a task, you're deploying a pod, you're deploying a Lambda function, you're deploying an application. Those become your first order bits. That's where you get build. That's what you attach networks to. That's what you attach data stores to. It's a much nicer model, but we also have to build tools to help you do that much more easily. But I think it's super, super important that we start thinking about how we remove the complexity that we've added over the last few years, where you have to start thinking about everything it takes to do cluster management or even multi-cluster management. Seems like a waste of time. Now, the reality is not everybody's ready for that. People have to start simple. They have to start with something they understand. So they are very likely going to start running containers on EC2 instances. That's fine. But over time, they want to maybe move to Fargate. And the constant challenge that we hear from our customers is, should I start there? Should I move there over time? And they challenged us to help make it easier for them to make that decision, or at least make it a late binding decision. So yesterday, we launched this concept called capacity providers for ECS. And a capacity provider, I think, returns us back to this concept of where capacity is just capacity. And the ECS schedulers and your APIs decide how and where your application should run based on what you tell us. So today, ECS supports two types of capacity providers. The first one is auto-scaling groups, which is essentially EC2 instances. The second one is Fargate. And the fun part is you can basically say in a config file that I want 80% of my application of this service to run on on-demand instances and another 20% on spot. If the spot capacity goes away, the traffic gets weighted off to the on-demand stuff. If the spot capacity comes back, you'll start running 20% spot again. You are not doing anything. The scheduler is doing that for you because you've declared in a declarative config file that you want 20% of your application running on spot instances. You can do the same thing with Fargate, and in case you missed it, we also launched Fargate Spot yesterday. So Fargate allows you to do savings plan for long-term discounts. You have on-demand, and now you have spot as well. That's great. You can have a capacity provider that's just EC2 instances. You can have a capacity provider that's Fargate. That's what we can do today. But here's where we're going with this. You can mix and match capacity providers. We don't do this today. It's going to come hopefully early next year, which is you can start off by running everything on EC2 instances. Slowly over time, by just changing a config file, you said, no, I want more of my application to run on Fargate. And you can go one step further and say, oh, by the way, of the stuff that's running on Fargate, run 90% of that on spot instances. Or you can burst from running on EC2 instances, and then anytime opportunistically Fargate spot capacity is available, run it for me. So essentially what you've done is you made things declarative. You made figuring out what the right capacity is and how to run it our problem. You're not thinking about it explicitly. And if you squint hard, you can take this concept a little bit further. We also launched ECS for Outpost yesterday. There's nothing that says Outpost can't be a capacity provider for ECS, or wavelength, or a local zone. And your scheduler, in theory, should be able to decide, yeah, looks like there's capacity in this Outpost over there. I'm going to run this service over there, and then run it inside an AWS region when there's capacity available there. So that's the idea that we have of taking and abstracting away capacity management, which clusters, as we know them, brought back and made them your problem, and we don't want that to be the case. So we're super excited about this kind of capability and what it enables our customers to do. A great example of a customer that's adopted serverless containers for a couple of reasons is Vanguard. Vanguard, for those of you who don't know, is one of the largest investment companies in the planet. They manage a $5 trillion, they're $5 trillion under management. And they had some specific needs. They are a regulated company. They have a lot of high security web applications. They want hardening of the container boundary. In a pre-Fargate world, what they would have to do is figure out, here are all their clusters, which applications can run next to each other, should they have soft multi-tenancy versus hard multi-tenancy. With Fargate, they don't have to think about it. Everything by definition has hard multi-tenancy. That's a decision that's been taken away from them. It's accidental complexity they don't have to think about. Every task gets its own network interface. Now you don't have to figure out whether networks, two tasks on the same host are sharing network fairly or not. That's gone away as well. So that's an example of continuing to abstract away this accidental complexity, and we believe very strongly that serverless, whether it's containers or Lambda, do a great job of taking that away from you. So, Vanguard's pretty much moved everything over to Fargate for a bunch of applications that have regulatory requirements, and that's kind of amazing to see. The other thing we needed to do, Fargate's great. ECS customers got to have all the fun. What about all the Kubernetes folks? A lot of the things I say about cluster complexity comes from the fact that Kubernetes is a single tenant, and every cluster has its own database and its own control plane, which adds a lot of complexity from an operational standpoint. Now, the best part is, yesterday we launched Fargate for EKS. What that allows you to do is take Kubernetes pods and run them on Fargate. You get the same hard isolation. Everything's at the pod level. Your pod is effectively a node. And so the operational complexity just goes away significantly and allows you to focus just on your pods and just on your services. And we think that model is going to evolve over time. And if you attend some of the other deep dives on Fargate talks at reInvent, you'll realize that we're thinking further about how do we make it easy for you to build your own orchestration on Fargate over time, not just depend on AWS orchestrator. So let's get back sort of to the operational model that we have at AWS. I wasn't kidding when we say we draw 3 or 4 lines. I said 5, it's more like 3. There's EC2, it's right at the bottom of the stack. The line's halfway through the box. You have ECS and EKS. With capacity providers, with managed nodes for EKS, you are taking some of the accidental complexity away by managing the capacity pools that your applications run on and having to spend less time thinking about them. With Fargate, you take that even one step further by making capacity not your problem, period. It's our problem. Running it efficiently is our problem. Lambda is the extreme case where you're just deploying these little tiny functions and really quickly with high concurrency and not having to worry about how do you build a control plane or management plane with a container orchestrator that can handle that complexity. So that's great. We have multiple lines. So far, I've just talked about Fargate. I'm the container guy, I like it. But let's talk about Lambda as well.
Deepak, actually, could I interrupt and jump in here?
You want to?
Yeah.
Okay.
Yeah,
Thanks,
operations is kind of messy, so why don't I just jump in? Thank you, Deepak. Okay, so we gave you sort of this very clean theory of operations, and it's what we strive for, but of course, sometimes things are a little messy and we can't quite live up to that. So we're constantly trying to improve operations. And one place where we know we've kind of let you down in the past has been the network performance or cold start performance of Lambda functions when you were using them with VPC functions. So for the past year or so, a little bit over a year, we've been working on radically changing how Lambda functions are able to use VPCs to really just eliminate all of that. And we were excited to finish that up just last week, right before reInvent. So working with our partners in EC2 networking and their hyperplane capability, we've basically made a VPC to VPC NAT so that now, rather than needing to scale up your VPC connections as your Lambda concurrency scales up, we just do it one time when you either create a function or update a function. So that process can take a little bit longer now, but we've not only eliminated the latency that comes with connecting new functions to your VPC, we've also eliminated your need to scale the number of IP addresses to your Lambda concurrency. So hopefully we've taken a lot of operational muck away so that you just don't have to worry about that at all. On the other hand, there are some times when you know more than we do, and giving you just a few operational controls can let you continue to have an overall serverless experience where you, for the most part, can hand off operational responsibilities to us, but you can use your knowledge to improve your overall operation. And so over the last few weeks, we've added a lot of new capabilities with Lambda to make it easier to work with asynchronous and streaming integrations. So if you're working with Kinesis streams or DynamoDB streams, you now have greater control for both sort of low infrequent as well as super high volume cases. So we launched something called batch window, where instead of waiting for literally a full batch size, you could set a time limit. So if you had rather infrequent Kinesis streams, you didn't have to worry that if you set too big a batch size, you might go hours without an invoke. You can set a time limit. On the other hand, if you have a super high volume Kinesis stream or DynamoDB stream, but you don't want to have to reshard, you can now set a parallelization factor with Lambda, so we'll actually scale out and do anywhere from 1 to 10 batches in parallel. We, along with that, have added new logic so you can enhance retries and error handling, so you can set a max age, you can bisect, really just wanting to give you some more capabilities so you can continue to operate in a serverless fashion, but on a range of data streams. And then finally, sometimes what we do to improve operations is actually just replace a bunch of muck that you've had to do in the past. So with Lambda, with async functions, they just kind of end. We didn't really give you much help with that. So you could write logic to publish the results somewhere, but that was code you had to write. And so good news now with Lambda destinations, you can just eliminate that. And instead, when you configure your function, you can configure it to deliver a result to one of many destinations. Could be another Lambda function, could be an SNS topic, could be an SQ. And that way, you can now move into configuration what before you had to own in code. But in that sort of same spirit of sometimes we want to give you just a few knobs, we're really excited last night to launch Lambda Provision Concurrency. And this is a capability that allows you to sort of address super latency sensitive applications, those where all of the work that we're doing to reduce cold starts hasn't been enough. Maybe because even after we've eliminated that network latency and the work that we did last year with Firecracker, the cold start times were still too much for your latency sensitive applications. Or maybe because your own code needed to take too long to do its initialization phase. So now we've added a new capability so that you can have consistent double-digit millisecond start times on your functions by provisioning a set of concurrency ahead of time. And it's very dynamic. This is not well, I can only do it like once a day or once a month or something like that. You can change this every few minutes. It actually comes with a set of metrics that will tell you about your concurrency. And so you can even hook that up to auto-scaling. So if you have a nice sort of time of day predictive workload, you can hook that up to auto-scaling. If you know that you have an event coming, you can provision that yourself, and you can turn it up and you can turn it down. You can even combine it with burstability. So if you know that you only want to deliver a consistent performance experience and you'd rather deliver errors, you can set that at a cap. Or if you want to be able to take on more traffic than expected, it can burst in the normal way. So really, our whole thought process on this was, we don't want you to have to leave Lambda if you have an application where cold starts interfered with what you wanted to accomplish. Instead, we wanted you to just be able to add in this new capability, keeping everything else the same. Your function code doesn't change. Lots of customers will have a same function running purely on demand most of the time, and only in particular events will they provision concurrency. So we didn't want you to have to leave the realm of Lambda. So we're looking forward to seeing how customers use this. And we know that the way you'll use it is you need an ecosystem of support. So we were also very happy to have many of our partners in the provisioning and monitoring ecosystem build in support for provision concurrency at launch. So thank you to all of these partners for doing that. So another thing we know is your architectures are a long-term bet. And recently, AWS announced a new way to commit to purchasing EC2 instances and Fargate called Savings Plan. And just as a preview announcement, coming early next year, you will now also be able to have those commitments apply to Lambda. So we want to make sure that as your architecture evolves, you don't feel that your financial commitment has been stranded and that that's a reason why you can't evolve and adjust your architecture over time. So Lambda will be fully fungible within your commitment in Savings Plan. So overall, as Deepak said, our goal is really at the end of the day to help you innovate, to help you deliver as much business value as possible, as rapidly as possible. And we know that operations is hard. It's a critical part of working in the cloud. So wherever we can, we want to provide some strong leverage, some gears that you can use at whatever level is appropriate for running your business. But hopefully over time, we can eliminate more and more of that so you can focus just on business logic. Okay, so this is where I was supposed to come in. Sorry, I can't go more than a few hours without talking about operations or I get jittery. So hi, I'm David. As Deepak mentioned, I lead our serverless portfolio. And so I wanted to talk about application patterns, architecture patterns, which really, at the end of the day, come down to being about communication patterns. It's why Deepak started out by talking about two pizza teams. A two pizza team is just there to limit the number of people who have to talk with each other to make a decision. Because decision making is hard, and the more people involved, the harder that is. So that's about communication management, and so are architecture patterns. I really think about the earliest days of the internet, the earliest days of the web, and I think one of the architecture patterns that has led to so much of the innovation we've seen over the last 20, 30 years can be called small pieces loosely joined. The idea that you really want to be able to innovate in just little incremental areas. Sometimes that lets you do something big and huge, sometimes small and incremental, but the more that you can do that independently with loose communication, leveraging what's already out there, the greater your ability to innovate, and especially to innovate on a lot of fronts all at the same time. So, we think about there being kind of three core architecture patterns that support this. API or request-driven, request-reply-driven systems, event-driven systems, and data stream-driven systems. So we'll talk about those. And I tend to think about APIs as the front door of microservices. They really are that little bit of guarantee that the engineering team makes to everybody else that says, this is what I'm promising I'm going to deliver to you. And then behind that front door, they can do whatever they want. As long as they don't change that contract, they're free to innovate, whether that's to change the implementation, to add new capabilities, to performance optimize. That front door is critical. And so inside of Amazon, we even talk about that as our relationship between two pizza teams. We talk about APIs as hardened contracts. That's the thing that is a high judgment to change. But if it's not in the API, you're free to innovate. And so, even something as simple as that still requires work. There are lots of properties of a well-mannered API. Usually you want to do metrics generation, you want to do throttling, you want to do some type of access control, you want the ability to evolve your API, maybe to generate SDKs. And so API Gateway is there to help so that you don't have to spend your time innovating in just what it means to have a normal, well-factored API. You can innovate on what that API provides. And so API Gateway can act as that front door and is capable of integrating with a wide array of systems behind the scenes, whether those are Lambda functions or containers or instances. It can even talk back to legacy systems on premise by using VPC and Direct Connect. So we have customers like Realtor.com who are able to use API Gateway as a large part of how they serve their customers. Anybody who's ever bought an apartment or a house knows that it's a very visual experience. And so Realtor.com serves hundreds of millions of images every day, mostly through API Gateway and using the caching that's built into API Gateway to be able to support that load. But we know that sometimes API Gateway has been perceived as too expensive or too slow. And so later this afternoon, we are going to launch in preview a new version of HTTP APIs that are designed to be up to 70% lower cost, up to 50% lower latency, that will support built-in standard support for OAuth and OIDC, and a simpler getting started experience, more of a one-click rather than the multiple steps you need today to define your APIs. So we're hopeful that this can help you embrace API management in places where it may have been cost prohibitive or not have the latency or simplicity that you needed before. So APIs are kind of present no matter how you're building things. They're definitely present in a request-reply architecture. But one of the other common architecture patterns is event-driven, and that's one of the most common ways that people build real-world serverless architectures. This allows them to have this nice property of decoupling services that can scale independently. In a way, it's sort of a back-to-the-future architecture. Enterprise message buses became quite popular in the late 80s, early 90s, in many ways for the same sort of reason. Enterprises are complex, evolving organizations, whether it's through mergers and acquisitions or trying to enter into new business initiatives or understanding some places need to be optimized. And so that idea of loose coupling, where you can have a common place, a message bus, a pub sub system where you can publish interesting information from one set of systems that can be consumed and reacted to in other parts is a kind of long-lived architecture pattern. And so, we try to provide a large number of services that you can build in this architectural style. Whether it's an event sourcing pattern like with Kinesis or DynamoDB streams, or some of our core event-oriented offerings to help just manage topics and queues and events. Our goal is to have a set of capabilities that can remove a lot of the muck of building an architecture this way by being able to operate the infrastructure on your behalf. And so it can really span from these sort of old traditional enterprise applications all the way up to very modern IoT systems, which also tend to publish facts, or to modern messaging systems. And so customers are able to use simple queue service, and we've recently added support so that you can now have ordering. So we launched SQS FIFO, and Lambda recently added the ability to have native integration to process messages in order. With SNS, our notification service, we recently added dead letter queue capabilities so that you can control what happens to a message if it isn't processed within the time that you'd like. And then within events, we've recently kind of taken our existing CloudWatch event system and doubled down on it to create the Amazon Event Bridge service. And I wanted to talk a little bit about that. So we really see events, which can be just very simple facts about things that have happened in systems, as one of the core ways of building cloud-native applications. And a vast majority of AWS customers already program with the events that almost every AWS service generates through CloudWatch events. And recognizing that, we thought, well, we're happy that customers are using the AWS events and that they're also publishing their own custom events, but we wanted to make sure that as you all use more and more software as a service providers, you're able to program in the same way. And so over the summer, partnering with about 10 software as a service providers such as PagerDuty and Zendesk, we added the ability to very easily have your SaaS provider publish events into the bus that you can then program with in the same way that you can program with AWS native events. And so we're happy to have a couple new partners who just recently announced, including MongoDB and their managed MongoDB service. So there's a lot of things that you have to do, though, when you develop with events. You have to have a way to publish events, and we're working on making that easier. You also have to have a way to consume events and to program with them. And to be honest, this is a place where traditional APIs, request-reply APIs, have had better developer support. You could really work with them at the level of a type, rather than just a set of strings or JSON that you had to figure out how to parse. And so we've wanted to try to simplify that. And so Monday night at Midnight Madness, we launched a new ability to create a schema registry and automatically discover the schemas that are flowing through your event systems. So you don't have, you can, there are APIs to program and create a new schema if that is what you want to do. But for an even easier experience, you can just turn on discovery on your CloudWatch event bus, and it will automatically detect the keys and the types of those keys and publish them into a registry. And then we have a set of language bindings. So I thought I'd show you just a short demo, because really the goal of that is to enhance developer experience. We wanted you in your IDE, whatever that may be, to be able to have the same strong typing support and auto-completion support that you have existing with traditional APIs, also with event APIs. So as I mentioned, we recently had MongoDB come and join as an event source. And so this is the sort of experience you would have, integrating, activating your SaaS account to start to publish into the event bridge. So it's about as simple as that. And so once you've completed that on the SaaS side, you can go into Event Bridge and start to interact with this new stream of events, such as by looking at the discovered schemas that the system has registered from that bus. And so that's nice on the console, but where it really gets interesting is to start to move into your IDE, where you can also browse the schemas in your IDE and take a look at those. And so, it just shows up as a JSON. But then when you go to actually program with these, you'll see that it can show up inside a project that you create in your code. You'll be able to have the normal sorts of experience of browsing and tab expanding and having getters and setters and the usual sorts of things that will make it easy to work with events. Okay. So as I mentioned, this is in preview. We'd love to get your feedback as you use it, and we plan to roll this out early next year. So request reply APIs as the front door, event driven, whether that's simple events on the bus or topics or queues. And the third major architectural pattern is really data streams. And this can span a pretty broad range. It can be data streams as events, such as if you need strong ordering and want to use an event sourcing type of pattern, which works really well with DynamoDB streams, where you're probably already interacting with the database, and it sort of gives you almost like a transaction journal that other systems can be driven off of, or Kinesis streams. But then it's also quite common for customers to use especially Kinesis streams as a very large volume data processing system. And so that can be a great kind of connective tissue between different portions of your system at high data volumes. And that's why we launched those recent capabilities. But we know that sometimes what you have to interact with are not sort of all brand new to the cloud native style architectures like data streams, but instead you have to work with existing relational databases. And to be honest, that's been a challenge with Lambda, because they just have different design centers. With Lambda, compute is very ephemeral and it scales up near instantly to as many instances of concurrency as you want and then scales back down. Whereas databases with their connection pooling approach tend to want not quite as dynamic a range. And so customers who've tried to drive high scale or high burst workloads against relational databases have had to go through more operational muck than we would have liked. So partnering with our RDS colleagues, we've built basically a proxy that can help with that connection pooling. And so we announced this in preview earlier this week, where the idea is you can kind of think of it as two sides of the relationship between your compute and your database. And the side between the proxy and the database can basically be owned by a database administrator. And it can scale at kind of the normal connection rates that a typical client of a database would. But then on the Lambda side, that can scale to the sort of big peak to average ratios that you're used to with Lambda functions. And the proxy can be smart about reusing those connections and multiplexing that so you don't have to worry about that. That's its main goal. But we also know that managing security with databases can be challenging. Nobody really likes having to distribute the database credentials out to every function, let alone maybe the hundreds of different versions of functions that might need credentials. And so you've been able to use Secrets Manager to do that, but it's kind of unsettling. And so the other thing that we've done is make it so that you can split the security responsibilities. So now only the proxy has to know about the actual database credentials. And again, that can be controlled by the database administrator. And then you can use IAM between the Lambda functions and their role and the proxy so that you can use cloud native auth to control that side of the experience. So along with these kind of three key architectural patterns of APIs, events, and data streams, we know that most real-world applications need some amount of coordination. Especially in a serverless world where you're often working with multiple services together to leverage each of their capabilities, it can be helpful to have some coordination. You can do that in code, but sometimes it's nice to be able to move that into a dedicated service that's focused on that and where you can observe what's happening in a workflow. And so many customers use step functions for that. But just like with API Gateway, we know sometimes it's been too expensive and not low enough latency or high enough transaction rate for some of your workloads. The original design center of step functions, our standard workflows, is incredible durability and exactly once. You can run a workflow that could take up to a year to complete, and we have very strong exactly once guarantees. But that's over-engineered for some use cases. And so yesterday we announced in GA Express workflows, which are designed instead to be kind of paired with Lambda-type workloads that can be very ephemeral, very fast, where now you can do up to 100,000 streams per second. So much higher volume at a substantially lower price point, but shorter in duration, and with the trade-off that these will now be at least once rather than exactly once. So it's possible, though, to use these two workflows in combination. So if you have things that it's okay to restart, there's a little ephemerality, that's a great use case for Express workflows. If you have things where you really don't want to have to restart, you don't want to have to manage a lot of checkpointing yourself, you can use standard workflows, and they'll even compose together. So you could have a very long-lived workflow that may have relatively slow rates driven by standard workflows, but that in turn could drive high rates of Express workflows. So overall, our goal is to be able to help you deliver as much business innovation as possible, as rapidly as possible. And so we've sort of shared a set of our common practices, whether those are our software deployment, our operational model, or application development. And I think different customers go through different journeys in starting to adopt some of these. Sometimes it can be rather organic. It's pretty common, especially looking at use of Lambda, for people to start out with IT automation. It's really easy to just glue a few things together through all of the integrations. They may then move into data flow processing, because of the deep integration between Lambda and like Kinesis streams, where if you have a lot of data, usually you want to do some type of computation on it. And so it's quite easy to be able to just activate some Lambda functions, especially with the enhanced scaling controls that we've launched. And then often, as customers start to figure out their microservices strategy and how they want to build applications, they'll move into building serverless microservices. So that's a very common evolution. But sometimes what customers decide is, what I actually want to do is we call it a serverless first strategy. I would like to challenge my organization to, when we're building new applications, let's see if we can do it serverless first, and only convince ourselves that we can't before we take on some other technique. And really, again, the idea is to be able to have very rapid development, to be able to have fast time to market. That's really what this is about, is we want you to be able to deliver value to your business without having to manage a lot of undifferentiated stuff. And I think that's especially important in changing business conditions where business units all throughout, which may traditionally not have been very technical, need digital support. They need computational support. They need help from development teams. And so being able to respond rapidly, to iterate so that it's not a giant project, but instead something that we can experiment along the way, can really fit well with a serverless first approach. So no matter what approach you take, we really encourage you to think about, as you are deciding how to go about building cloud native applications, what approaches can you take that give you the most agility, so that you can experiment, you can iterate, you don't have to get locked into something that you decided several years ago and there's no way out. So take on practices, take on development techniques that help you with agility. Have us try to deliver as much elasticity for you as possible so that you're not in the midst of having to control and to provision everything. Think about only the parts of provisioning that you really need, where you know more than we do, where that lower gear is going to be more helpful to your business, and where possible, let us drive elasticity for you. I can tell you it's a huge area where we continue to invest. Every place that we add a capability to let you provision behind the scenes, we're also doing as much as we can to innovate so you never have to use that capability, so we can just figure it out for you. And then finally, looking at the total cost efficiency, which is hard, and we keep trying to give you more guidance so that you can predict those costs. But that's a whole range from the literal infrastructure, how well you utilize the infrastructure. Can you use things like auto-scaling or built-in scaling and elasticity of services so you don't have to figure that out, as well as your development costs? So I know that's a whole bunch of stuff, and it's a lot of practices and can feel overwhelming. If I can leave you with one thing, it's just go build. Inside of Amazon, we have a leadership principle we call bias for action. And that's because there's nothing that teaches you more than doing things. So we hope that you'll take advantage of these offerings, just start building something, give us feedback as you do. We really appreciate you coming out and spending the week with us at reInvent and here. And we'll be available off to the side if anybody has any questions. So thank you very much.
Thank you.